All right, I want you to have your notes out, and as we go through this introduction to inequalities, I'd like you to be taking notes on your paper, as we normally would do in class. And then when we finish our notes, you can work on your homework assignment on the same sheet of paper, and then we'll go over this in class on Monday. So anyway, inequalities, we've been working with equations. Inequalities are a little bit different because they do things like this. And you can put down for number one in your notes, we can talk about the driving age. And I think it may have changed a little bit recently, but let's say that you have to be at least 16 to be able to drive legally in the United States. And this was also our starter problem for today, so you should have this and have a good idea of what we're talking about already. At least 16 to drive. And so we want to talk about what this means and write an inequality and graph this. So if X represents how old you can be to drive, we have to have some way to represent that has to be 16. It could be equal to 16. So when you turn 16, you legally can drive. Actually, I think it's 16 and a half. But we're going to go with 16. It could be 16, but it can also be greater than 16. So an inequality is not just an equal sign, an equation with an equal sign. That's what an equation is. An inequality has as its verb, the math verb, is it could be equal or greater than to. And that's what this symbol means here. If X is greater than or equal to 16, the way that this would look like if we graph it would be we have 16, we have 17-year-olds, we have 15-year-olds, and we can go forever to the left or forever to the right. But 16-year-olds could drive. So could anybody who is greater than that. So 17, 18, and all the way up. And so I would graph an inequality that looks like this. Another inequality that we could use to represent, that we can write in English that we can represent with an inequality and an inequality graph would be something like this. If you go to an amusement park, a lot of times in order to ride a roller coaster, you have to be a certain height. Okay, let's say that height is that you have to be greater than 42 inches in order to ride a roller coaster. Well, if you're 42 inches, that won't cut it. You'll be right at the verge of going on, but this says you have to be greater than 14, and so this inequality would look something like this. If n represents the number of people that can go, or anybody that can go, that person has to be, it cannot be equal to 42 inches. Their height has to be greater than 42 inches. I want you to look at the similarities here. This is greater than 16 or equal to 16. That's what the little line, the equal sign underneath the inequality represents. This is greater than or equal to 16, which means it includes 16, which is a closed circle. This down here, n is greater than 42. If we graph this one, it's going to be similar to the graph up here, except if this is 42 inches and this is 43 inches and 41 inches down here, I'm going to put an open circle around 42 because 42 inches isn't going to be a solution to that inequality. You have to be greater than 42 inches. Now, you could be 42 and a half or 42 and a fourth or even 42 and 100th, but 42 inches isn't going to work. And so this inequality, the graph, looks like this. I want you to notice the difference here. If it's greater than or equal to, it's a closed circle. Here we're shading to the right because it's greater than 16. If it is just greater than 42, it's an open circle because the 42 is not included in this. We can do similar inequalities. One that would be something that we can relate to instead of people who can drive or what you can do on a roller coaster. It might be eating free. Okay, let's say that you go into a restaurant and it says that you can be, if you are less than 12 years of age, you eat free. Okay, less than 12, maybe your salad bar is free, or maybe your meal is free that night. If you're less than 12, so let's write an inequality. The people that would eat free would be the people, let's say that they are X. Would a 12-year-old be able to eat free? Is a 12-year-old less than 12? Well, a 12-year-old is equal to 12. So a 12-year-old wouldn't work. It would only be those people who are less than 12. So it would look like this. The graph, here's 12, here's 13, here's 11. The graph would not include 12-year-olds, so it would be an open circle at 12, and I would include all the people who are less than 12. 10-year-olds, 11-year-olds, 11-and-a-half-year-olds would work, but not anybody who is 12. And again, it's an open circle. There's no less than or equal to here. The only closed circle we had so far was the very first one, because it was greater than or equal to, and that's a closed circle. Okay? So let's say another place that you might want to go out to eat is Chuck E. Cheese, and you can go in those tubes and run around or crawl around, I guess, in Chuck E. Cheese. But let's say that there's a sign that says you must be 10 or less to go in the tubes. If it is 10 or less, if you went there and you were 10, could you go in the tubes? And yeah, because you are 10. Or you could be less than that. So this sign would look something like this. Your age could be less than, or it could be equal to 10. And in this particular case, if this is the graph, here we have 10-year-olds. It's going to be a closed circle because those 10-year-olds get to climb around the tubes. Here's 9, here's 11, and anybody who is less than that. So when we graph our inequalities, we're going to graph them with either closed circles or open circles, and then we're either going to shade to the left, like these two, if they're less than, or we're going to shade to the right, like these two, if they're greater than. One more thing I want to talk about, and I want you to put in your notes, is what does it mean to be a solution of an inequality? And so you can put up at the top here a solution to an inequality. We're going to have pretty complicated inequalities, but let's say that we have an inequality that looks something like this. 3x minus 9 is less than 15. A solution is anything that would work. I'm 44 years old, and so I'm a solution to the fact that I can drive. I can also go on roller coasters because I'm older than 42 years, or I'm taller than 42 inches. I couldn't eat at the restaurant for free because I'm older than 12, and I wouldn't be able to climb around in the Chuck E. Cheese tubes because I'm too old for that. So I wouldn't be a solution for those two. But let's just check some of these out here. Let's say that we try 5. Is 5 a solution to this inequality? Well, in order to figure that out, we're going to plug 5 in for x. 3 times 5 is 15. 15 minus 9 is 6. And 6 is less than 15. So 5 is yes, it is a solution. We could try something like 10. Is 10 a solution? Well, if I plug in 10, 3 times 10 is 30. 30 minus 9 is 21. But 21 isn't less than 15. So 10 would be no, it's not a solution. Let's try something like 8 though. If I plug in the number 8, 3 times 8 is 24. And 24 minus 9 is 15. But is 15 less than 15? And the answer there would be no. It would work if there was an inequality sign under it that looked something like this. That would mean everything that works that would be less than or equal to 15. And if it was equal to like this, then we'd have to change this no to a yes. But the way that it is right now, if it's just less than 15, then 8 is not a solution for that. So we're eventually going to be solving equations like this and graphing these, but on your homework for tonight, you just have to say whether or not something is a solution or not. Last thing you'll be doing on your homework assignment tonight, and what I'd like for us to do right now is if I give you a graph, I would like for you to be able to write an equation or an inequality that describes it. Like, for example, if this is 5 and there's a closed circle and we're going in this direction, what is an inequality that would describe this graph? We're talking about 5. I want all the numbers. 5 is included because it's an open circle. I want all the numbers that includes 5 and all the numbers that are greater than 5. And so 6 works, 7 works, 8 works. All of these numbers are in the shaded part, but 4 does not work. Okay. On the other hand, if I had something that looked like this, it was an open circle. Let's say this is 2, and this is 1, and this is 3, and I was shading down here like this, then 2 is going to be part of my graph. It's going to be a boundary, but it might look something like this. I want the values of x that are less than 2, but 2 would not be included because there is an open circle at 2. You can rewind this video if you get lost on something or get confused on something, and watch it as many times as you want. But what I'd like for you to do at this point is draw a line underneath these notes, draw a line down your paper, a third of the way on your paper, and I would like for you to do your homework in this area here. And we are on page 136, and we're going to be doing numbers 2 through 36 even. And when you come to class on Monday, I'd like for you to have those problems completed. If you have questions, we'll go over it then at that time. Have a good weekend.